Hello students, now in this video also let us solve some more non-homogeneous recurrence relations. So let me write the example. Solve the non-homogeneous Now the given relation will be, suppose the first one, it will be AR minus 4 AR minus 1 plus 4 AR minus 2 is equal to R plus 1 into 2 raised to R with A0 is equal to 2 and A1 equal to 40. Okay, now let us solve this recurrence relation. So now solution. Now here, first of all, for solving this recurrence relation, you know from previous video, we need to solve the associated homogeneous equation to get homogeneous solution, and also using this f of r we will get the particular solution. Fine. So let me write the associated homogeneous equation is, what does that? It will be AR minus 4 AR minus 1 plus 4 AR minus 2 is equal to what? 0. So now let us write the characteristic equation from this, and let me find the characteristic roots to write down the homogeneous solution. So here the characteristic equation is it will be alpha square minus 4 alpha plus 4 is equal to what? 0. Why does this? Here this it will about 2 r minus 2, so our power of alpha will be 2. Already I had been explained it before also. Fine. So now if you feel the check this one, this is nothing but alpha minus 2 square is equal to 0. So this gives us alpha equal to 2 comma 2. These are the two roots that are what? The characteristic roots are repeated characteristic roots. Okay, therefore the homogeneous solution is it will be ARH is equal to A1 plus RA2 into 2 raised to what? R. Fine. So now this is a homogeneous solution. We will go for the particular solution. So for that we have to check what is f of r. F of r is r plus 1 into 2 raised to r. It will be r plus 1 into 2 raised to r. So this is of the kind, so polynomial into lambda raised to r. So now lambda is the root here. So where alpha equal to 2 is the characteristic root. Okay, therefore characteristic root of multiplicity 2, because it is what? Multiplicity 2, because it is repeated. Fine. Therefore using the general form of particular solution, we get ARP is what? P0 plus P1R into R square 2 raised to R. This will be our particular solution. Now, to find the values of P0 and P1, we need to substitute this particular solution in a given recurrence relation. Therefore, the given recurrence relation becomes it will be AR means the same. It will be what? P0 plus P1R into R square 2 raised to R minus 4 times AR minus 1. So, it will be P0 plus P1 into R minus 1 into R minus 1 square into 2 raised to R minus 1 plus 4 into what? R minus 2. So, P0 plus P1 into R minus 2 into R minus 2 square into 2 raised to R minus 2. And that is equal to R plus 1 into 2 raised to R, f of R. Fine. So, now let us simplify it. Now, here this 2 raised to R minus 2 we can take common. So, let me take 2 raised to R minus 2 common. So, what is left here? Here 2 square will left. Here 2 will left. Here 1 will left. Fine. So, 2 square into R square. That will be 4R square. So, let us multiply by 4R square to this one. So, it will be 4P0R square plus 4P1R cube minus same thing will be here. Here 2 will be left. 2 into 4 will be 8. So, it will be 8 into what does this? This is P0 plus P1R minus P1 into another bracket will be this one here. It will be R square minus 2R plus 1. Okay. Again, here, let us see here. Here 4 will left. 1 will left. So, this 4 as it is. 4 into what is here? This what are the two brackets here? P0 plus P1R minus 2P1 into R square minus 4R plus 4. That is equal to R plus 1 into 2 raised to R. 2 raised to R. So, let us write down here also 4 into 2 raised to R minus 2. Let me write here. It will be R plus 1 into 4 into 2 raised to R minus 2. So, this 2 raised to R minus 2, 2 raised to R minus 2 get cancelled. Now, let us simplify it. While simplifying all these things, and the right hand side will be what? 4 into R plus 1. When you will simplify all those things, you will get it as such. It will be 24P1R minus 24P1 plus 8P0 equal to this one 4R plus 4. So, now compare this the coefficient of R with R and the constant with constant. So, this will give us 24P1 equal to 4 and minus 24P1 plus 8P0 equal to what? 4. So, this gives us P1 is equal to what? 4 by 24. So, it will be 1 by 6 and P0 will be, P1 will be 1 by 6. So, here we will put up here, it will be 1. P0 will be 1. Now, put up them in this particular solution. Therefore, ARP is what? 1 plus 1 by 6R into R square 2 raised to R. So, now particular solution is this, is a particular solution. Is a particular solution. Therefore, the general solution is, general solution AR will be ARH plus ARP. So it will be A1 plus RA2 into 2 raised to R plus 1 plus 1 by 6 into R square 2 raised to R. This is our general solution. Now our last aim to determine the values of A1 and A2 using initial conditions. So now A0 is equal to 2. So that gives us R will be 0. This is AR. R will be 0. Put up R will be 0 here. Here R is 0. So this will become 0. Here only A1 will left from this bracket. And here we will get 1. Okay. Here R will be 0. So the whole term will become 0 because of this R square. So we will get directly A1 is equal to what? 2. Now the another initial condition is what? A1 equal to 14. Means R is equal to 1. So here we will get, it will be A1 plus A2 into 2. It will be A1 plus A2 into what? 2 plus what is here? Here we will get 1 plus 1 by 6 into again here also 2. So it will become, that is equal to what? 14. So it will be what here? Here 2 and this will be 1 by 3. 2 and 1 by 3. So this 2 is also here. 2 we can take common, shift it to right hand side. So that will become 7. So A1 plus A2 plus this part. It is how much? 7 by 6 equal to what? 7. So that will be A1 plus A2 equal to 7 minus 7 by 6. So it will be 35 by 6. So A1 plus A2 will be 35 by 6. But A1 is equal to 2. We can get the value of A2 from it. So we will get, hence, we have A1 is equal to 2. Therefore, A2 is equal to what? 35 by 6 minus A1. A1 is 2. So 35 by 6 minus 2. So it will be 35 minus 12 upon 6. So it is how much? It will be 23 by 6. A2 is 23 by 6. Therefore, our AR will be what? Here AR we will get 2 plus 23 by 6 into R into 2 raised to R plus 1 plus 1 by 6 times R into 2 raised to R into R square. This is our final solution here. Final solution of this non-homogeneous recurrence relation. Now let us solve one more example of the same kind. The second recurrence relation will be, suppose AR minus 6 AR minus 1 plus 8 AR minus 2 is equal to 2 raised to R plus 3R plus 5. Now again the same thing, we will find a homogeneous solution, particular solution separately, and then find the values of the constants in homogeneous solution. Now here the initial conditions are A0 is equal to 11 and A1 is equal to 18. So solution, the associated homogeneous equation is, what does it? AR minus 6 AR minus 1 plus 8 AR minus 2 is equal to 0. So from this we will write the characteristic equation. Therefore the characteristic equation is alpha square minus 6 alpha plus 8 is equal to what? 0. Now if we find the roots of it, we will get the factors are alpha minus 2 and alpha minus 4, because the product should be plus 8 and sum should be minus 6. So it will happen from these two numbers. So now we will get alpha is equal to 2 and 4 and are distinct roots, are distinct characteristic roots, are distinct characteristic roots. Therefore, the homogeneous solution is will be ARH is equal to what? A1 into 2 raised to R plus A2 into 4 raised to R, as they are distinct. Fine. Now, f of R is equal to 2 raised to R plus 3R plus 5. Therefore, it is not of same kind, which is what? Is an addition of lambda raised to R and the polynomial. Addition of 2 raised to R and 3R plus 5. Also, 2 is the characteristic root. Lambda raised to R, so lambda is the characteristic root. Characteristic root of multiplicity 1, and alpha equal to 1 is not a characteristic root. Therefore, by the general form of particular solution, we get the particular solution will be what? P0 plus P1R plus P3 or P2 R into 2 raised to R. It will be as such. Fine. Now, let us find the values of these three constant first. Therefore, the given recurrence relation becomes it will be what? AR. So the same one, P0 plus P1R plus P2 R into 2 raised to R. Fine. Minus 6 into P0 plus P1 into R minus 1 plus P2 R minus 1 into 2 raised to R minus 1 plus 8 into P0 plus P1 R minus 2 plus P2 into R minus 2 into 2 raised to R minus 2, and that is equal to 2 raised to R plus 3R plus 5. Now, let us simplify it. While simplifying, we will get P0 plus P1R plus P2 2 raised to R into R minus 6 P0 minus 6 P1R plus 6 P1 minus 3 P2 R 2 raised to R. Okay. Again, plus 3 P2 2 raised to R plus 8 P0 plus 8 P1R minus 16 P1 plus 2 P2 R 2 raised to R minus 4 P2 2 raised to R, and that is equal to 2 raised to R plus 3R plus 5. Okay. So, this gives us some of the terms get cancelled and some of get simplified. So, it will be minus P2 2 raised to R plus 3p1 r minus 10p1 plus 3p0 is equal to 2 raised to r plus 3r plus 5. So now while comparing, this gives us minus p2 is equal to 1, 3p1 is equal to 3 and 10p1 minus 10p1 plus 3p0 is equal to what? 5. So this gives p2 is equal to minus 1, p1 is equal to what? 1. So put up p1 here, so that will become minus 10 will become plus 10. So sorry, plus 10 on this side. So 15 divided by 3, so it will be 3. 15 divided by 3 will be 5, sorry. So p0 will be what? 5. So there we get ARP, or the particular solution will be what? 5 plus r plus, it will be minus r 2 raised to r is a particular solution. Therefore, the general solution is it is AR is equal to ARH plus ARP. So it is A1 2 raised to r plus A2 4 raised to r plus 5 plus r minus r 2 raised to r. So our aim to determine the values of A1 and A2 now. Here A0 is equal to 11. So we will get, so that gives us A1 plus A2, put up r is equal to 0 here, plus 5 is equal to what? 11. So that gives us A1 plus A2 is equal to what? 6. And A1 equal to 18. So that gives us 2A1 plus 4A2 plus 5 plus 1 minus 2. Fine. So 5 plus 1, 6 minus 2 will be 4 equal to what? 18. 18 minus 4 will be 16. So 2 plus 4A2 is equal to 16. Okay. And that is same as A1 plus A2 is equal to what? A1 plus 2A1 plus 4A2, not 16, it will be 14. 18 minus 4 will be 14. So it will as such. Now solving these two equations for A1, A2, we get, solving for A1 and A2, we get A1 equal to 5 and A2 equal to what? 1. Okay. Now A1 5, A2 1, put up them in this general solution. That will be our required solution for the given recurrence relation. Therefore, the required solution hence the required solution is what? AR is equal to 5 into 2 raised to r plus 4 raised to r plus 5 plus r minus r 2 raised to r. This is our required solution. Now here our chapter 4, that is recurrence relation, will be over, and also the syllabus of discrete mathematics is also over. Now if you have any doubt, you can ask me either on WhatsApp group or on Google Classroom. Okay, thank you.